Hey everyone, I'm Jim here with my dog Java, and we're both here to present on how to share data sets in a post-quantum future. I thought what better way to live and breathe the QForce Fellows Program than to do a project myself. So very excited to be here and uh, immerse myself in the experience. First things first, what is the problem we're going after? So Databoard exists going after this problem. Over 50% of enterprises still store data unencrypted and sensitive data unencrypted and are at risk of breaches with sensitive data. Moreover, a lot of enterprises use multiple clouds. Some use AWS with GCP, with Azure, and it's hard to navigate where all the data is across all the cloud providers and even third-party vendors. So how do you discover data sets? Moreover, encryption is painful. A lot of enterprises use Amazon Key Management Service or other similar key management systems and find it hard to manage keys for data sets. And lastly, we're seeing an increased number of data breaches, especially in healthcare, and the cost per breach is up to almost $10 million a breach, which this is up over 30% year over year. So data breaches are becoming bigger and more expensive. Beyond all that, we're seeing even more data published online. Over 180 zettabytes of data will be on the web by 2025. It's like equating to 6 to 10 million Google searches a minute. It's a lot of data going through the web. And moreover, we're seeing the quantum threat really accelerating over the next 10 years as encryption is being threatened with more sufficiently powered quantum computers. And the time to kind of update and update legacy systems to this new quantum encryption could take upwards of 10 years, as shown below, with the Moscow model adopted from cryptology archives. And so how do we kind of respond to this craziness in publishing and packaging data sets and responding to threats and encryption? So Databoard exists to make the process of creating and distributing data sets as simple and safe as possible. It's sort of like a GitHub for data. We can create and publish data sets with inherent safety built in with encryption and other techniques that are state-of-the-art in quantum to make it easy to store data in a safe way. In doing so and creating a community like this, it improves dataset discoverability, makes the idea of implementing quantum encryption painless, starting from a blank slate as opposed to legacy systems for startups and early stage companies, reduces the risks of data breaches, assuming that the encryption has been vetted by NIST and other standards, and also makes the digital disposal and deletion of data easy for PHI and GDPR compliance. We built this on top of a Flask monolithic architecture. Basically, everything is contained within a virtual machine with a SQLite data store. So everything is serverless in terms of data store for prototyping. We built everything on top of Python and Flask just for demo purposes, but it was almost 15,000 lines of code we wrote. And also there's a notion of development and production environment using DigitalOcean spaces for storage of data just for demo purposes here. So let's get to the demo. So we have right now an account we just made. This is all live at localhost. First things first, let's try to just show you how easy it is to make a data set. So let's go in here, create a QForce demo data set. So we're going to go in here. You could select a schema. So if you wanted to enforce a data schema, you can. In this case, it's just uploading an audio file. You could specify a size, which is the limit in terms of data set size, by which you'll stop letting uploads available above the size. You can also make the data set public or private. In this case, it'll default to private for security. You could specify the license. The standard license just means that you own your data, and then you can encrypt your data samples with whatever encryption method you want. In this case, just showing an example encryption with a Fernet key as a basis for demo purpose. You then have your link to your data set and you can upload data. So let me go in here and just do a quick demo of how easy it is to upload. Let's do tests. So I have a test file in here, test.wave. So let's just upload an audio file. Again, this is a token generated upon login. So this is only valid for a few hours. But you can see here now, there is a data set that has now one sample. It has two operations. It uploaded the sample, which is create sample, and it encrypted the sample. And it stored this, you can see in right here on spaces, which is DigitalOcean spaces. I can even also present this data really easily, visually in a nice PowerPoint. And it has all the API routes to manage the data set direct within this PowerPoint, which is pretty nice. So presentability of data is one aspect. The other is downloading the data. So since this is all encrypted on Spaces, the process of downloading it is really easy. All it does is basically takes the encrypted file off of Spaces and decrypts it with a local virtual machine in DigitalOcean, or locally, in this case locally, and downloads the data and decrypts it within the key stored in the SQLite data store. And you can see this is the audio file I uploaded with this. And you can see quickly that you can kind of scale your data sets. You could also see the schema by which is enforced here. And moreover, there's one powerful concept with Databoard is that you can be extensible data sets, as in you can extend them infinitely through web browsers, which is a little different than other marketplaces. In this case, if you wanted to upload more audio data, you actually could through a web browser. And in doing so, you can kind of span data sets that are convenient beyond technical users. So you can see here, two samples now. The survey sample is uploaded as well and continues to grow. If I keep uploading, say I want to keep uploading more data, which I already have it up here, just upload a few more samples. At some point, it'll stop uploading because it reaches its limit, its data set limit. Let's see, one more. I think this will show it. So you've reached your storage limit. So I think this notion of storage limits is very powerful with data stores and data sets generally. You could also see that all of this has uploaded the commit log. So there's a pretty clear commit log in archive of all of your data sets. And you can see all the limits of your data here to upgrade. So why is this important? Well, it saves you lots of time. It saves you time to create and publish data sets, create protocols for surveys and share data sets, and manage things via API. This can go from months of creating and sharing data sets to minutes in a compliant way. It also makes it easy to basically be flexible for organizations and other sharing mechanisms for others to replicate and follow, and is competitive with other exchanges out there. The vision here is to incorporate quantum encryption, much like the other forms of encryption, onto the data store and make it easy to create and publish data sets like GitHub for Data in a way that's fully compliant. And that's sort of the next phase of this project. Some traction. We've created the logo and brand kit. 15,000 lines have been committed. There's a client library. Some beta users generate data sets have been created. Some organizational accounts have been created. Just the example I gave here, and a domain name secured. He's seeking to continue developing and do discovery of customers and certifications for HIPAA, SOC 2, and FedRAMP later to see if this is a way that customers would find useful versus, say, other marketplaces like Snowflake. In addition, looking to find co-developers and maintainers for this project, potentially open sourcing this, and refactoring some of this code in Go and Rust. So I've grown a lot from this project. I've learned how to really go from an idea to a beta, learn a lot about API design, REST API design and creation, especially with permissions, role-based permissions for APIs. I've also learned a lot about the landscape for storage. Where should you put stuff? Should you put it in DigitalOcean Spaces, Amazon S3, FTP, or any alternative? And encrypting data and packaging them for these storage systems. I think there's a lot there to learn and grow, especially with quantum encryption. I think there's a lot about data marketplaces I looked into and learned about how to license and package data sets as streaming license or non-streaming, and also practical applications for quantum encryption. I think this is one area among many that people could start making this technology more accessible and easy to use for the non-technical user. I envision one day this can be as easy as things like Google Drive and Dropbox for anyone to go in and use quantum encryption. I want to send a big thank you to the whole QuForce community, especially Patrick and Rebecca and Ethan, who've been at me at weekly meetings over the past 6 months to really drive this community forward. And all of you here at Demo Day, I really appreciate you participating and being involved here. So much we can do to educate the quantum community. Thanks all, and I hope you enjoy the rest of Demo Day.